Unit 2 Chemistry, Chapter 15, Part 2. Strong or weak acids. So, here we have an example of a base and an acid. Okay? Now, one of the things that's commonly asked is how can you tell if it's an acid or a base? Well, look, in general, if it's got OH minus in it, then it's a base. Okay, so if it's got a hydroxide ion, it's a base. If it's got hydrogen in it, it's normally an acid. Okay. However, I just told you this was a base. This is a base called ammonia. This is one of those exceptions that you're just going to have to remember. So anytime you see NH3, you need to remember that that is a base. So being an acid and a base, they come together and they exchange a proton. So the ammonia grabs a proton and becomes ammonium. The hydrogen, of course, gives it up and becomes its conjugate base. Okay? So we go from hydrochloric acid to the chloride ion. Okay? Again here we can see example of an acid and its conjugate base. Water is able to be either a base or an acid. So in this case it can accept protons to make its conjugate acid. But if we put it with ammonia, then it's going to act as the acid, donate the proton to become hydroxide ions. And this is going to act as a base and make its conjugate acid, the ammonium ion. Some of these are strong acids, some of these are weak. So this process of donating protons we can call ionizing. If they give them away really easily, so there's basically none of the unreacted acid molecules left, then it's a very strong acid. So hydrochloric acid is a good example of that. It takes all of its protons that are in the HCl, gives them to water, and it's basically all left as chloride ions. But a weak acid, like ethanoic acid, or indeed any of the organic acids, so if you see anything with the COOH group, the carboxylic acid group, they're all weak acids. So only a portion of them is given away. For all of the organic acids, the proton we're giving away is the one at the end of the COOH group, okay, to make the COO minus. So these ones here, they're not going to get given away. Okay. When we look at it in solution, lots of the molecule is left as this. Very little of it has become that. Okay, so what we've got here is a double-headed arrow, which shows the reaction goes in both ways. And in the case of ethanoic acid, it's less than 1% of the molecule that actually reacts. So if you've got 100 molecules sitting in solution, one of them might turn from this into that. Strong bases, same idea. If it's a strong base, then it will readily accept protons, and that's going to result in the formation of hydroxide ions. Because if you have a strong base, the ions react with water, disassociating it, and we're going to get hydroxide ions made. Okay, so sometimes it's a one-step, sometimes it's a two-step process, but something like sodium oxide splits up and gives you sodium and oxide ions. The oxide ions then react with the water, so they accept protons from the water to make two different hydroxide ions. So we always get hydroxide ions, it's just a matter of what the process is that we go through to get it. A weak base, like this ammonia we were looking at before that you've got to remember, that one is only going to accept them very weakly. Okay, so again we'd use a double-headed arrow to show that. We're still making hydroxide ions, but again if we had maybe 100 molecules of ammonia, we might react 5 of them to make 5 hydroxide molecules. Okay. The stronger the acid, the weaker its conjugate bases, and vice versa. So a very strong conjugate base will give you a very weak acid. Now, some acids can donate more than one proton. Some can donate 2 or 3. Okay? If they do it more than once, then they are donating them in multiple steps. So they don't give them all away at the same time. They give one away, then a second one, then a third one if they got one to give. And they might give away the first one really readily, so there'd be a strong acid for the first donation, but then get progressively weaker or more reluctant to give it away as you go down. So something like sulfuric acid, it's a diprotic acid, which means it's got 2 protons to give away. In the first ionisation, it gives away 1 proton to make the hydrogen sulfide ion and 1 hydronium. And here it's being a strong acid, so sulfuric acid is strong. This hydrogen sulfate ion can then give away its proton, so react with more water to make the sulfate ion, okay, and some more hydronium. This, however, is a weak acid. Okay? Anytime you're going to look at the solution, you'll have some of these, some of them, and some of these ions being made. Okay?